Hi, everybody. My name is Peter Schoberg, and I'm a go-to-market specialist here at Amazon Web Services for the S3 portfolio products. Today, we're going to be talking about the optimization of cost using Amazon S3. A little bit of our agenda, we'll talk about the portfolio overall, and then we'll get into how do we optimize costs across the different storage classes. A little bit about what you're going to hear is background on S3 and how we use it, but it's going to orient towards how we optimize our costs and use S3 to save money as best we can, and then pull it all together to be the most effective portfolio of storage that we can use. Let me give you a little background on S3 as an overview. S3 is part of a broad portfolio of storage services at AWS. In the upper left, you see block storage. Block storage obviously is a huge part of a portfolio of any storage, and there's a tremendous amount of capability tied to our compute environments. And as we look at transforming applications and moving them into the cloud, our block storage portfolio supports servers closely aligned to lifting and shifting and bringing applications into the cloud. Of course, as you rehost applications and you move them into new application environments, sometimes changes and modifications are best made to re-platform using things like the AWS family of file storage. In the upper right, you see some of the capabilities we have across different file storage solutions that are part of the Amazon AWS portfolio. And then, of course, today we'll dive in and talk about Amazon S3, the object storage portfolio with multiple classes of storage that meet a variety of business needs. Important to note, there's a number of services that ingest data into S3 and into AWS storage overall through our data transfer capabilities, and we're always conscious of the ability to protect and manage storage using things like AWS Backup, as well as a variety of other technologies that are part of our partner portfolio in AWS storage. Let's move forward and talk about Amazon S3 and specifically how folks are optimizing cost using that portfolio. Amazon S3 offers industry-leading scalability, availability, security, and performance. This is a technology that was launched back in 2006, and you see a little bit about how over time we've seen this environment grow and be leveraged by millions of customers storing exabytes of data. When you think about object storage and how it can scale, the ability for Amazon S3 to bring together trillions of objects from around the world and service the needs of enterprise customers in all walks and all applications is central to what S3 is all about. We regularly peak at millions of requests per second around how much throughput we do with Amazon S3. In a single region, we can see as high as 60 terabits a day processed through Amazon S3. In addition, of course, inside of the availability zones per region, we support 235 distributed microservices. So while you think about S3, keep in mind what you're looking at is a tremendous portfolio that supports a variety of different capabilities in an environment. It has done so for nearly 14 years now, and is doing so to the tune of exabytes of data. This is a powerful storage offering, and as you look at your mental model of how to leverage this, it's important that you keep in mind how it can be taken advantage to support your business at an optimal cost. Because as we scale and as we leverage storage, we want to make sure we're thinking about the most efficient way to use it to support our business and achieve our outcomes. So let's get into the notion of cost optimization in Amazon S3. When we start thinking about cost optimization, we want to create a framework or a way to view the different pillars of cost optimization. There's several areas we will investigate that are important to recognize, each of which has an important element to support how we use S3 and how we manage our costs. Really important about this is to think about things like your application requirements. And while data is a foundational element of a lot of our applications, it is those requirements that are central to what we're doing in an environment. Defining the application requirements and understanding how it's going to be used. For instance, if it's supporting web content for something like random access or high availability or durability, or if you're going to do some analytics of the data. Again, these are really important factors when you think about how to leverage your data in S3. Another key part is going to be organizing your data. So with this quantity of information that we're able to manage in S3, organization is a very powerful element and to be considered from the beginning of how we use S3 and store our data. And to be able to apply not just these macro concepts of how we organize data, but down to the individual object level, data organization is going to have an important part about how we see cost optimization becoming realized. Third on this list is right sizing and understanding the right sizing of how we leverage the different classes of storage and how we utilize some of the configuration capabilities. And then lastly, the ability to monitor, analyze, and optimize over time. Because the one thing we know about storage is its needs and its usage will change. So we bring to bear tools like CloudWatch and CloudTrail, things you would be familiar with in an AWS environment, or storage class analysis that will help us to monitor and analyze in order to continue the optimization. And while we have 4 distinct pillars, we'll dive deep into each of these. It's important to note that they have different impacts on our ability to optimize costs and the ability to leverage to meet our business needs. And this all begins with our application environment. So first up, let's talk about defining our application requirements. So when you step back and look at S3, you really have customers across all industries and all kinds of workloads using S3. Some are doing things like big data analysis or a large-scale content distribution. And when you step back and look at how they leverage access like through mobile devices or how they protect their data for something like disaster recovery, it's really important that you think, what does my application require? So to begin with, you look at things like durability and redundancy. How much of that is necessary within our data? So normally data is a central element of an application, and durability and reliability is going to be very important. But for your data sets, think about how many copies you have and where they're located. Is this a secondary copy, for example? And do I have different levels of durability that I require for my data? Similar to durability is availability. The availability concepts are, of course, oriented to how that data is accessed over time. How much uptime do we need to have? What type of application environment does it support? As we think about this, we must be aware that the availability characteristics, while extremely high across classes of S3, they do vary, and we want to make sure we're applying those to the needs of the application. Then we start thinking about how the data is going to be used. Things like access frequency. How often is the data accessed? How much is it going to be used? Does that access pattern change over time? That will quickly lead us to think about things like performance. What type of performance do we need out of our data? And if you see here in the S3 space on that side, the object size, what does the performance look like for the different file and data types that we've been storing in our object store? So object size can have an important relationship to things like how frequently we access and the performance of our data. So it is this, along with how long we keep that data and its useful purpose to the business. Things like the duration. We see data that is used today immediately and accessible right away as we've loaded it into S3. And then over time, its access frequency perhaps goes down, but we still may need to maintain that data for a period of time that allows us to get to that data should we need it for something like archival purposes or a longer term use. And of course, don't lose sight of the fact that within the S3 environment, that data that was used to serve your business may be governed and needs some regulatory oversight. So the data needs to be preserved and maintained for a certain amount of time. All of these are driven by the application requirements and are central to the beginning of our cost optimization. So think application, what it needs, and then we're able to move into how to better leverage our costs or save our costs in different aspects of S3. The next important point to think about is how this data is organized. With such a massive amount of data being stored in S3, organization is paramount. There are a couple of key characteristics to organize data in S3, and some of which, of course, many users of S3 are familiar with. But it's important to think about how all of these can relate together to give us the greatest advantage. This second pillar looks at three key ways of organization. The first being the bucket, the location of that data, the name of that bucket, and how that is being organized. Normally, buckets have some association to their application or a business or a line of business. And understand that within a single bucket, you are able to put in multiple classes of storage, so you can serve a lot of different needs out of that single bucket name. Of course, when you move on, you may start needing to organize with prefixes. Prefixes allow us to define individual locations of a group of objects that are related to one another. That prefix name is the definition of how we will access the object according to its identity and its path. So prefixes also allow us a degree of organization. Lastly, and maybe most important to our organization, is object tags. Now, tagging is an option that you can put on individual objects, either as they're brought into your bucket or later on as you organize and create some structure around the information. You can add up to 10 tags, or metadata tags as we call them, that are a key value pair, allowing you the chance to directly organize according to the specifics of something like a project, or whether a data is confidential, and maybe even things like the creator, owner, and other details that allow you a great deal of granularity in that organization. This fine-grained management is really important when you look at things like setting permissions on individual objects and even moving objects based on a life cycle. So keep in mind that the bucket, the prefix, and the object tag are very important. And what's central to this is being able to set this up at the beginning for easy cost optimization. Because if after the fact, our environment has grown, become a little bit convoluted and somewhat difficult to manage, these things are harder to apply later. And as we've seen in the scale of S3, things can get quite big. You can, of course, maintain a lot of this information and review it in things like your CloudWatch metrics, and understanding how these filters are set up. Those are important things to be able to do when you start looking at your data so that you know what you're storing, how it's being stored, and why. One of the things we found as a best practice beyond just organizing this data from the beginning is understanding and maintaining the knowledge of what it is that you're storing. We find organizations can easily create copies or replicas of data and move information around, and keeping track of that without things like tags or specific prefix organization can be very problematic. So organizations start from the beginning with a structure, and then they apply that structure to the data. Now, if you think about this, this is not uncommon in a lot of data structure projects, databases of different size and design. But of course, we're talking about this in the concept of Amazon S3 as the object store. So let's take a look at those objects themselves and think a little bit about the format that that object comes into and how we're choosing to store it. Now, there's really three factors that relate here when we decide on what we store and the format in which we store the data. And there isn't a single right answer. The idea is best practices say to think about your format when you begin the process of storing your information in this area. How will we manage the ability to support different costs and different performance requirements in the data that we ingest? So many folks choose their S3 bucket in order to put data in that is raw or gold copy, or that is at its origin. Some of that data will come in necessarily as unstructured formats that are not as easy to understand. They're easy to understand, but are harder to process. They take a little bit more work to pull out key pieces of information. Now, depending on that type of object, that might be exactly what you need. If you're storing images or large-scale file formats, you may realize that that object is going to be wholly used the way it sits. But objects that are allowing us to store individual pieces of information, can have different formats that allow for greater efficiency, both inherent in being able to compress the data and also to query and find information within the data. So formats you see here listed like unstructured formats such as CSV, TSV, or JSON, XML, very useful, but slightly unstructured. Think about whether that data should be in a format like a Parquet data, ORC, or Carbon data, because we now find ourselves that it's easier to compress some formats and store it more efficiently. Others are easier to use and access more quickly. The other bit, of course, is do you need to store data in a raw format and then potentially create optimized versions of it for use differently inside of something like a data lake? This becomes a very common use case, and efficient data formats are central to both the cost savings process and the performance gains that you can get. So what is very important to us is as we run through this is to think, what type of data do I need to store? Not just now at the onset of our project, but as I look down the road and I think about how over time I'm going to be able to use this information. So think ahead, and that's very important as not only we plan out the organization and we plan out the format, but even the class of storage that we're going to choose. So when I think about these characteristics, you think back to what we mentioned about what an application requires. So the third pillar is really looking at how to right size the class according to the storage class that you have available to you. And these characteristics, which we've been talking about regarding your application, such as redundancy and availability, lend you to decide on the most appropriate class of storage and how they fit. And as we said, storage class is an important part of this conversation because your storage costs can vary by over 95% by choosing different storage capabilities in storage, a different storage class. The characteristics of each class are central to this conversation as we move forward. So for example, if we start with the concept of durability. Now the durability is very important to understand, and it relates to the data that we store and our likelihood of losing data. Absolutely heart-wrenching when we think about this happening. And it's why S3 classes are built with 11 nines of durability. That means that for every 10 million objects, you can expect to lose on average a single object every 10,000 years. So there's a lot in that, but think about what that means. It means the likelihood of losing the data is very, very low, and durability is central to what we do with our data, meaning preserving it so we can use it going forward. Next to that are the concepts of redundancy and availability. Now, redundancy refers to things like how many availability zones do we have? So for Amazon S3, we have a variety of options that meet different what we'll call availability zone criteria. Now, these can be thought of as facilities, locations in which we store data, and these are very important when you design how I lay out my data in a location, and I build them for my availability characteristics. So you see here a couple of examples of whether or not you need an availability criteria that's very high, say 4 nines of availability across that class, or whether you could expect to have your business survive with slightly less availability. Now, it's very important to understand that impact. And again, these are driven by the application. Maybe more important, though, is things like access time from your application. The access and the frequency of access is very central to the conversation. For example, can you access that data really quickly, and do you need it within milliseconds? So access can be tied to performance and how much data is brought back over what period of time. And think about whether those access times are synchronous, virtually real time, or they could be asynchronous as part of your workflow. Of course, the different classes of storage function differently. Think also about how big the objects are going to be and how they're going to be stored, and then how we look into the individual duration for that object. I'm going to hit on this point again because reducing the storage costs maybe the greatest way to do that is always around choosing a storage class that best fits your workload. We see users in all classes of AWS storage understanding that this cost savings can dramatically change their ability not just to use the different classes of S3 differently for their application, but to take better use of storage funding and apply it in other areas of their data processing. And of course, when we look at S3, we're talking about this 11 nines of durability across the entire AWS storage cloud. Now, today, that includes 24 regions and 76 availability zones. Now, keep in mind what we speak of when we mention a region, because out in the industry, people use these terms differently. When we're talking about a region, this is a geographic location with multiple physically separated availability zones. So these are separate facilities linked together in a certain geography. The availability zones represent those individual facility and locations where objects are stored across, spanning a minimum of 3 availability zones. So there's math out there that you can do on things like durability, but understanding that the ability to be in physically separate locations that have redundant power and cooling and network connectivity is central to achieving not just the durability that you see here, but also that availability that we spoke of. And so knowing how the design of AWS storage with its 24 regions and 76 availability zones allows you to confidently choose the right type of architecture that you can look at for optimal performance in also understanding your data durability and, of course, security. So we look at these very critically across all areas of our storage classes, and we use that to drive much of our cost consideration. Now, the last pillar that we get into is looking at how we monitor, analyze, and optimize our use of storage. This, of course, is our storage use over time. So it's very important to understand from the very beginning how you design your system of storage within S3, but it's also important to look at it over time. We see organizations that have a decent understanding of S3 when they begin, and they begin to leverage it in a certain very specific manner. But over time, their needs change. For instance, their data might become less frequently accessed. Maybe wasn't something they either knew or part of their workload changed. So over time, being able to monitor that data and then decide on how it can function best is central. We have different characteristics for this, including monitoring the data real time, as well as understanding access patterns. So many tools are available to you as an S3 user. In the monitoring, we can look at things like the S3 inventory or the ability to leverage CloudWatch and even accessing the server access logs of S3. Such data is ongoing and gives us good guidance as to what we're doing within S3. But allowing S3 to analyze the use through storage class analysis is another key part of our optimization. And then understanding that we can perform things like different calls in our data with things like batch operations. Batch operations, and we'll double click on that in a little bit here to know more about how we can perform operations against millions, even billions of objects with single API calls that allows us to make the action against an object that is more important. Also, very, very key is how we use lifecycle policies and even leverage S3 intelligent tiering, a class of storage that will automatically seek cost optimization on our behalf. We'll double click onto some of these areas and know that these different areas of monitoring, analyzing, optimizing, and managing storage are key to the ongoing savings, so that your best practice isn't just to set up the environment and let it run, but it is to go back over your workflow, perform things like inventories or storage class analysis, learning what your data is doing, and taking action against your data. Because this type of work leads you to either leverage automatic transition of data or the ability to create a life cycle to move from, let's say, a standard class to an infrequent access class of S3 storage to generate that type of savings. So key to this, monitoring and managing your environment is just one of 4 pillars. Lots of options here. We want to spend more time going forward now on how we adopt different storage classes and how they are specifically used in our environment. One important note, this should be true of nearly every AWS service that you're exposed to. We look at AWS as a group of services that operate under some very simple principles. Those principles are things like the lack of requirement on upfront investment. Of course, this pay-as-you-go approach means there's nothing upfront and you pay for what you use. Think about the difference in a monthly budget versus buying and having on-premises equipment that, use it or not, is already costing you the same amount. Within AWS, for every service, we look at how you pay for that as you use it. And then, of course, the ability to scale. Scaling the environment changes how you pay because price breaks as you pay less by using more become available in storage as well as in other services. And lastly, one of the fundamental principles is that as AWS grows, you pay less. This concept maybe is best demonstrated in S3 when we look at the history of decreasing storage prices with S3 over time. So yes, when we launched this service in 2006, we looked at how we could optimize with different classes of storage and then drove down over 80% savings over time. That allows us to take savings out of our efficiency and turn them into lower cost to you. And that is 15 or so percent savings to you every year. That's for customers. That's part of what's native to this environment. But not just decreasing storage prices by making things more efficient. You see on the right, the ability to accelerate innovation, the ability to basically take new technologies and bring them to market that reach different price points. And you see that since 2006 and as recently as late 2019, we launched storage classes that meet additional requirements in the market and then allow for savings to be passed on to you. I want to spend a little bit more time looking at these, and some of our newest tiers bring some of the greatest savings and the ability to optimize. Let's take a double click on the storage classes to make sure you're aware of all of these characteristics. In general, the S3 storage classes are separated from our frequent access to infrequent to archive. So let's take the first two, the standard class and the infrequent access class. Standard is the, of course, original class of storage that gives you millisecond access and is available in at least 3 availability zones for every region in which it operates. Of course, that's every region. Now, when we look at that data, it is designed, that class of storage, it is designed for data that is active and frequently used as part of our production environments. Compare that to an infrequent access class that generates over 40% savings by storing the data in similar architectures with similar characteristics where there is minimum duration and a minimum object size, and there's a fee for retrieval. These are well suited to generate savings for data that isn't going to be accessed as frequently. And understanding that is very key to our business. Now, what we've realized is that both of these classes have the same availability and durability characteristics. And then we look at one zone, which was introduced to provide a single zone, giving the same level of durability that meets a different availability characteristics. Again, we're able to generate further savings with S3 one zone infrequent access. And this could be a great location for data that is less accessed or recreatable, such as copies of data from other locations. And we see folks create different copies in different locations to take full advantage of this. Now, of course, S3 Glacier is a class very different that is really seen as an archive or a repository for long-term preservation. The recovery of this type of data or retrieval is asynchronously, meaning it will take minutes to hours to get our data back. But again, the price point at 0.4 of a cent here, public pricing, you can see the ability to store data at far less money for a certain amount of time. Again, you do have minimum storage duration and minimum object size consideration. These classes of storage, which have been around for several years within AWS, have served a great deal of need, and you can decide on how to leverage those with things like your understanding of the data that we talked about and the use of our lifecycle policies. However, introduced rather recently is the intelligent tiering class of S3, which allows you to support data with changing access patterns, allowing for the same millisecond response time, but for data to move between a standard availability class and an infrequent access class. This type of storage is powerful because it represents common use of data where data is stored for a period of time and used, but then as it ages, it is no longer accessed and can be moved to generate that cost savings automatically. There are characteristics like monitoring that object to make sure we understand when it's used, and even a minimum storage duration in the class. But this automated tiering in the S3 intelligent tiering is a great value to those that have changing patterns and can leverage this in our environment. Lastly, we have our lowest cost storage, S3 Glacier Deep Archive. This is the lowest cost storage in the cloud that operates in a multi-availability environment. This is for long-term data, applications that maybe were originally kept on tape, and is ideal for storing data for a longer period of time, and has, of course, its minimum storage duration and object size. Recovery from this tier is on the order of hours, and it can generate such savings that it's well worth understanding the different classes of data as we embark on our environments and set up our applications. Now let's take a little bit of a look into some of these classes a little bit more carefully. The S3 intelligent tiering world is the cloud's only tier to provide automated cost savings. The ability to look at the changing access patterns, and keep in mind that as access of the data is across two different areas, frequent and infrequent. Such monitoring will then determine if an object is no longer being used, that it can be placed down into the infrequent access tier. Now, this all happens with no performance impacts, no overhead, and even no retrieval fees. So this intelligence is offered directly to the class at generally savings of 40% between the two. That is tremendously important to people who have to use data in different patterns and ones that it's very hard to understand that pattern of data. The intelligent tiering class is very powerful, and customers of all sizes are adopting this and using the intelligent class to save on their cost of storage automatically as part of their environment. The intelligent tiering class, highly utilized in things like data lake structures, where lots of data is brought together. Some is going to be used a lot, and some won't be used nearly as much. Also, data workloads that are unpredictable, like big data analytics, where parts of the data gets analyzed very, very quickly, and then even some of that gets kept long tail, meaning data that needs to be made available but isn't used as regularly and needs to be accessed very quickly. Across this class, the dynamic cost optimization with zero performance impact is very powerful and is leading this to one of the fastest growing storage classes we've seen within Amazon S3. Of course, intelligent tiering is one part of our savings, but the leverage of S3 in the Glacier Deep Archive class is absolutely one of the best ways to save money right away. This is designed for the same level of durability, those 11 nines, that allow you to get to your data as you seek it asynchronously. So this is over hours versus something like a tape-based recovery that might take you days or weeks. And at approximately $1 per terabyte per month, you can see this is less than a quarter of the cost of S3 Glacier. So the cost savings with this environment as a fully managed class of storage without any magnetic tape to manage or any kind of environment to deal with is available to you as part of your class. And you see people using S3 Glacier Deep Archive in a variety of different environments. So for example, compliance environments that need to preserve data for long periods of time, financial services or healthcare, or those looking to build a disaster recovery environment. Simply being the lowest cost storage in the market, this too is extremely fast growing and brings to bear such cost savings that every S3 customer should be looking to take advantage of this when they consider cost optimization. I want to shift gears a little bit and provide some guidelines and some design patterns so that folks can understand a little bit better on how to monitor and use their environment to provide for these cost optimization savings. So, as we talked about, monitoring your environment with the tools within AWS that are given to you are very important. The ability to know your usage and how you would budget for that over time is part of AWS budgets. And we see this as very important for folks planning on their spend as they evolve into new projects. And of course, CloudWatch is there and available to you to see things like what's going on within your environment and monitoring your metrics. It's very handy to set up alarms that will tell you when you hit a certain request count or transfer time in real time to know how your system is performing. The idea is you can achieve lower storage costs by staying within your budget, fewer surprises by monitoring your S3 environment. And this is really important when you look at the environments that you're operating against, including the different requirements that you might have with things like applications in data protection or in retention strategy. S3 is commonly used for protection of data for a lot of different environments, be that as data protection around backup and recovery, for accidental deletion, and even retaining that data over time. As we said, some folks are in a regulated market that might need to set that data to ensure it is not deleted for a certain amount of time, say 3 years or 7 years. Or they may need to be able to say, I have a second copy safely at a geographic distance that I control. All of these data protection and retention strategies are central to understanding, back to the beginning, your application and the environment you're going to use to store data within S3 to monitor and manage these optimal costs. Data protection is central to what we do as IT administrators. Anyone responsible of storage would think about that first, but doing so with the requirements of managing costs are how we see S3 with the various different classes of storage. Now, one capability within S3 that's very important to think about is how you might be able to leverage versioning and a strategy for keeping multiple versions of your data. When we enable versioning on an S3 bucket, we have the ability to create a new version for every time data is uploaded. We can then manage those versions based on our criteria. We could manage them by lifecycle, we could clean them up, we could set retention on them, we can do many different characteristics. And the idea here is to take advantage of what's inherently built into the system and make sure that our data is managed to our needs, such as, do we take a second version and enable that it is not deleted so that if we have a problem, a failure, an issue, we can go recover that data. So as that file comes in, I create a version of that file. If that file comes in, I can then create a second version, which is identified uniquely and separately. The idea is versioning is powerful. Many people take advantage of it for a variety of reasons. Clearly, creating these versions means I'm going to consume more storage and I need to be sensitive to how I manage my costs. There's great reasons to contain and manage versioning, not just to be able to take advantage of its capabilities, but also to watch those versions, perhaps put those down into lower costs of storage, or even delete them. One of the most powerful ways to manage our data is to be able to put it where it belongs, as I have multiple copies, multiple versions, and an integration of these storage classes with different costs. Beyond versioning is our ability to create replicas or replicate data to have uses in different areas. Now, replication has a lot of different use cases. And when we look across what we have within AWS, we see things like the ability to create a copy within a same region. That could be used for keeping a gold copy or keeping a copy available to other applications. I could, of course, replicate across region, CRR, and make a copy in a totally different location. In doing so, I could apply our object lock feature to that replica to ensure that it is never deleted or it's managed to my needs of things like compliance or governance. And we've recently introduced the ability to provide replication time control, which is to assure that my data is replicated and up to date within a certain amount of time. 99.99% of my data will be guaranteed to be replicated within a certain window, in our case, 15 minutes, and we can set events to manage that replication. This assurance of replication completing gives us a very strong understanding as to the consistency of our data and allows us to lower or manage our costs by knowing where these replicas live. So if I think about these different aspects of managing managing my storage, not only are versions and replications valuable to my business to place the data where it's needed, but how that data is accessed is also a big part of this conversation. Now, one thing we've recognized is not everyone understands their access patterns of storage before applications grow into large environments. So we have some general guidelines that we recommend. We look at how much we store and how much data is retrieved. Now, this is something that we would recommend you look at through our storage class analysis tools that look at your data to see its pattern of usage over time. Storage class analysis can even go as far as making recommendations when you see things, let's say in the middle, where access isn't as frequent, especially over time, that perhaps I can generate some savings by life cycling my data into things like the infrequent access or even the S3 one zone infrequent access. But when my access is changing, that's when I start to recognize the need for an intelligence to monitor and manage my data for me. So these processes are pretty important to how we look at data and how we use our ability to save over time. Taking a closer look at things like how intelligent tiering would work, in option 1 on the left, we have the ability to look at our class of data, let's say it's in standard, then understand through analysis how I might set up as a user the life cycling of data to different classes. Now, that requires me to know my data, to have studied it, and to make the actions to move that data based on things that we filter on, like bucket, prefix, or the object tags we spoke of. Fantastic if our data is predictable and we can set up that environment. Option 2 is when I can take advantage of the intelligent tiering class that would allow the class of data to automatically watch my data and then look at how I need to change where it's located based on the access pattern. That's critical. And one distinction that's very important to make here is that when I manage Lifecycle, it's based on the creation date of the object. And when the intelligent tiering of S3 manages it, it's based on the access of the data. So being able to leverage that and take advantage of these unpredictable workloads and still achieve savings, absolutely central. And then things like CloudWatch and our inventory reports can generate the information necessary about where our data is located and why. Absolutely part of this could be something like taking our S3 intelligent tier and pushing it down into lower costs over time. So for example, the ability to lifecycle out of the intelligent tier into Glacier or Glacier Deep Archive might be something that changes over the time, and I can then go set up patterns to take advantage of these archive classes or even expire my data. So when we look at our data and optimize it, the S3 storage class analysis can guide us for how the data is used, and we can set up the different patterns to, as we have predictable workloads, take full advantage of what the object age indicates and how frequently we access it to achieve maximum savings. Now, sometimes this is done automatically with the S3 intelligent tier. Sometimes I can take storage class analysis and it can tell me. But when I need to get to a granular level of working against my objects, the S3 batch operations allows me to do things at an individual object level in a very powerful way, depending on what that operation is. So when we have in the capability of batch operations is to take a report of all data and then take an action against that based on that report and then watch that happen over time. These actions could be replacing object tags, they could be running a Lambda function, they could be doing many different things against data. Batch operations is a powerful tool to put and use the data the way our business needs, all while managing the cost as effectively as possible. What's central to this is understanding and knowing things like the characteristics of our data set. What is it that we have, and how could we take advantage of it? When we know about our data set and we know things like the size of our objects, even how they're broken up into parts and stored, we can control those object sizes and place them under different management criteria. What's important here are things like batch operations, life cycles of data. They happen at an object level. So for our ability to bring objects together and group them, it can reduce our object count and allow us to manage data more carefully that puts data where it needs to be without incurring costs. The idea here is to better understand what classic characteristics our data has, and then understanding how we can organize and bring some of that together. Part of this is a concept of compacting smaller objects into bigger ones for greater cost efficiency. And the distribution that you see here tells us how many we have in different size and how much storage it consumes. So take advantage of these capabilities that are built in to really know how to provide for better performance, provide for better costs and provide for better performance. One area, of course, to note, as we mentioned, is looking at the synchronous or asynchronous access of your data. The ability to synchronously access your data and design an application environment to take advantage of it is central to how your data will operate in your application. The access patterns, how you need to recover that data, even how large that data is, all have different characteristics. So if you can understand whether your application can handle a synchronous or asynchronous access, you can then direct it into a storage class that's more suited for the different types of costs within a storage class. And performance against a storage class can be a major consideration for how we leverage S3 storage. And this is a broader conversation than we're able to have here. There's a lot more in AWS training that can get into how we operate different classes of storage at different performance and how you can design your environment to take advantage of this. Now, as we think about the power of the classes of S3 storage brought together, hopefully we recognize that the ability to provide performance, scalability, availability, and durability with a variety of different characteristics are inherent in how we have built S3. This ability to manage your objects even down to the lower object level, that granularity, gives you the ability to manage that data, optimize your costs, and use it as your business demands. Because what we find within S3 is, yes, storing the data, providing all the characteristics you need are essential. But perhaps the greatest advantage is how the data stored in S3 integrates with the breadth of services across S3. From just S3 Select, your ability to get data in and out of S3 and recognize what's inside of your objects, to having that data read into other services like Athena, Redshift, or even EMR. This is powerful, and optimized storage cost and performance allows you to take advantage of not just the storage, but a variety of different capabilities in S3 and across AWS. Now, as we look at where we are in operating our environment, one thing that we talked about at the very beginning was understanding your workload and your application. So when you look at something like a data lake, which is a common use case across S3, we want to look at how things like the right class of storage may fit for that application. So if you think about S3 as your data lake, drawing in a variety of different data types that have different characteristics, all brought together into a single repository is the very definition of the data lake. The idea then that data is accessed or used from its raw format, transformed into something that is a little bit more useful. That ETL process may actually transform and change the data, may delete some of the data, it may decide what is more relevant to an environment. That then ingests and moves our data into something like an intelligent class of S3. This then becomes the production data lake that is used to serve out data to a variety of other use cases, and it has an operational characteristic that meets our production needs. S3 intelligent tiering is a perfect example of that, where that data can be served to the variety of AWS services. And as it's used, it's served directly and easily. As it's not needed, it can put into a cost savings tier for infrequently accessed. And then, of course, over time, either the output or the data itself could be saved for longer term use into something like Glacier and Deep Archive. So even under the auspices of creating a data lake, understanding your workflow is central to your storage costs being managed through your environment. As we look at putting this all together, understanding how we look at our data in its needs is central. We've come back again many times to the application requirements and the ability to know what it is that our application will require. Then coming up to saying, let me organize that and make it as useful as possible, ideally ahead of time, and in cases even over time. Then, as I leverage our storage, the environment in which we operate has a tremendous impact on costs. That is specific to the different class of storage. I can then move in lifecycle data per object or tier, or tag, to leverage that possible cost savings. Now, when I'm integrated into my most cost-effective tier, then I have the ability to say what happens over time as I monitor, analyze, and manage this environment. Very, very important that we recognize that our storage is a dynamic environment and that the environment has changes that will come with it over time. Monitoring and analyzing it provides us with the ability to take advantage of the best cost price points. Then, if we look at two characteristics now within S3, the ability to take advantage of an intelligent tier which automates our cost savings between our standard and our infrequent capability or access of data, and then to take full advantage of the Glacier Deep Archive as the lowest priced cloud storage available, tremendously changes the cost profile that we have against S3. So I know there's been a lot here to go through today. Hopefully, you caught a couple of things that you can then take in, but do keep in mind that AWS offers a large degree of training and certification that can dive into each of these individual storage classes, their capabilities, and how we architect to ensure that this cost savings isn't just recognized from the very beginning, but also is part of how we operate storage over time, every day, as part of AWS. Thank you all for joining me today. Hopefully you found this informative. Take care.